This is Science of Class 9, Chapter 2. It is Part 3. Is matter around us pure? In the previous video, we have learnt that the particles of solution is less than 10 to the power minus 9 meter and the particles of suspension is greater than 10 to the power minus 7 meter. And between this range, the particles of colloid lie. Second, we have learned that solution and colloid are stable, but suspension is not stable. Solution does not show Tyndall effect, but colloid and suspension shows. In this video, we will see concentration of solution. So concentration of solution. When we talk about concentration of solution, it infers the relative proportion of solute and solvent in a solution. That is, if the concentration is high, it is known as concentrated solution, and if the concentration is low, it is known as dilute solution. And the amount of solute which can be dissolved in a solvent at a given temperature is called solubility of the solvent. So, if it is a solution, if it is a solvent, then the solid particles When dissolved in the solvent, it occupies the intermolecular space like this. And if the size of the particles of the solute is greater than the intermolecular space, then that solute will not be soluble in the solvent. Again, the amount of the solute depends upon the intermolecular space present in the solvent. If the intermolecular space is filled with the solute and if there is no more space, then no more solute can be dissolved in this solvent, and at that condition the solution will be regarded as a saturated solution. So when the solution refuses to dissolve more solute at a given temperature, it is called saturated solution. But when temperature is or heat is given to this one, heat is provided to the solution, that is, the temperature is raised, the randomness of these particles will increase, and when the randomness of the particle will increase, the intermolecular space will also increase, and when the intermolecular space is increased, then the solubility of the solvent will also increase. So at that condition the saturation will be disturbed, and when the saturation will be disturbed, then the solution may dissolve more solute in it. So as temperature increases, solubility increases, and so the saturation will be disturbed. In the same fashion, when the temperature is decreased, then the intermolecular space will be decreased due to the decrease in the randomness of the particles. Since the intermolecular space is decreased, therefore the solubility will also decrease, and then the extra dissolved solutes will come out of the solution. So when temperature decreases, solubility decreases, and the extra dissolved solutes come out of the solution. and this phenomenon is known as crystallization. Now we will see the ways by which concentration of solutes or solution can be expressed. So the ways in which concentration of solution can be expressed. Actually, there are several ways, but up to this standard, we will see only two ways. First is mass by mass percentage, that is concentration of solution equals mass of solute by mass of solution into 100. And another way is mass by volume percent, that is concentration of solution equals mass of solute by volume of solution into 100. So these are the two ways by which the concentration of mass of solution can be expressed. Here we will see an example to illustrate what we have just learned. If 50 gram of sugar is dissolved in 450 gram of water, find the concentration of solution formed. Now, how to solve this one? First, we will see what is given here. So, there's given mass of sugar, that is solute here, equals 50 grams, and mass of water, it is solvent here, is 450 gram, It is given here, it is 450 gram and it is 50 gram, that is solute is 50 gram and water is 450 gram. We have learned somewhere in this video that the component which has less amount is solid and the component which has more amount is solvent. So water is here solvent. Now we have to find out concentration of solution. Concentration of solution equals what? First here we'll have to find out mass of solution. So mass of solution equals mass of sugar plus mass of water. So mass of sugar is 50 gram plus mass of water is 450 gram equals 500 gram. Now concentration of solution. Equals concentration of solution. We can see here we have mass by mass cross factor, we have mass by mass percentage formula here. So this formula will be used. So the mass of solute will be 50 gram by mass of solution is 500 gram into 100. 50 10 times and by 10 times. So the answer will be 10%. So this part of video enabled us to understand that saturated solutions cannot dissolve more solutes. Saturation of solution can be altered by temperature, and concentration of solution can be calculated by mass of solute and mass or volume of solvent or solution. In the next part of this video, we will learn separation of components of mixture. So for that time being, stay subscribed. See you soon.